Hi everyone, welcome back. Today we are going to discuss about network in AKS. So network in a Kubernetes cluster is always the most difficult part to understand in my opinion, especially if you are new to it. So today I'm going to make it really easy for you. We're going to see the different services and objects in Kubernetes. Then we are going to discuss about CNI, what is a CNI, which one you should choose. And finally, we're going to see the different network services in Azure you can use with your AKS cluster. So let's get started. Okay, so now we can start by discussing about the different ways of exposing container or pod. As you know, pods are ephemeral, so IPs are not a way to communicate with other services. And also application can scale in Kubernetes, so deployment names cannot be used because they are randomized. So we are going to use Kubernetes services to expose applications internally and externally. And through services, we are going to be able to build highly available applications by load balancing your applications. Also, we'll be able to restrict the flow of network traffic through network policies. We'll see that later. And we can also configure traffic with SSL termination or routing on the layer 7. So let's start by discussing about the three first service types. So the first service type is a cluster IP. With cluster IP, you have a unique IP address to access the service, and it will handle the internal communication inside the cluster. So basically, cluster IP creates an internal IP address for use within the AKS cluster, and this service is typically good for internal-only application that support other workloads within the cluster. That's the default service type, and it's used if you don't explicitly specify a type for your service. NotPort will be suitable for testing and debugging because basically we'll be able to expose workloads outside the cluster on a specific port on all the nodes. As you can see, we have a range here, 30,000 to 32,768. You will be able to expose this port on each of your nodes and then route the traffic directly to your service and pods. As you can imagine, it's not perfectly suitable for production environment. It will be easier for us to use a load balancer service type or an ingress. So to begin with, the load balancer is going to expose workloads outside of the cluster, such as NotPort, but with a dedicated external load balancer. So in AKS, if you use a service type load balancer, it will create an Azure load balancer resource, configures an external IP address, and connects the requested pods to the load balancer backend pool. So it can be good if you have one application, but the problem is for each application, you're going to use an Azure load balancer. It can be very expensive. So our last option, and probably the best, is to use an ingress. So by using ingress controllers, we are going to work at layer 7, and it can use more intelligent rules to distribute applications traffic. Ingress controllers typically route HTTP traffic to different applications based on the inbound URL. So basically, ingress controller is like a reverse proxy in charge of receiving and routing external traffic to internal Kubernetes services. It's going to be a single entry point, and we'll see later that we can use application gateway for this. Okay, so now that we have seen the different services in Kubernetes we can use and the ingress option to expose our applications, you have to understand that a network plugin is required by an AKS cluster in order to facilitate pod-to-pod communication, pod-to-node communication, and in some case node-to-pod communication. There are basically two plugins available on AKS. The first one is KubeNet, and the second one is Azure CNI. You have more options, like using your own CNI, such as Cilium, Flannel, or Calico. But for this video, we'll be only focusing on the two main CNI, which are KubeNet and Azure CNI. So let's start by discussing about KubeNet. So by default, AKS cluster use KubeNet. And with KubeNet, an Azure Virtual Network subnet and route table are created automatically. With KubeNet, nodes receive an IP address from the Azure Virtual Network subnet. Pods receive an IP address from a logically different address space than the node pool subnet. And the network address translation, or NAT, is configured so that the pods can reach resources on the virtual network. Then we have the Azure CNI. It's a plugin that will be more complex but will offer more features. With Azure CNI, a pre-existing subnet on the virtual network are required in order to utilize the cluster. The size of your virtual network and its subnet must accommodate the number of pods you plan to run and the number of nodes you want. So with Azure CNI, nodes receive an IP address space from Azure Virtual Network subnet, and each pod receives an IP address in the nodes pool subnet. They can directly communicate with other pods and services. And with Azure CNI, your clusters can be as large as the IP address range you specify. However, the IP address range must be planned in advance, so that's the main concern you have. And all of the IP addresses are consumed by the AKS nodes based on the maximum number of pods that they can support. Okay, so now the question is, which CNI should I use? I would say it depends of your environment to begin with. For KubeNet, I would say that it's well suited for development and testing, and Azure CNI more for production environment. Indeed, we have seen that KubeNet is designed with the conservation of IP address space in mind, and Azure CNI provides pods with a complete network connectivity, but requires more IP address space and planning. Just to give you a quick example, with a simple /24 IP address range, with KubeNet you will be able to have like 251 nodes, and on Azure CNI, the same basic /24 subnet range could only support a maximum of 8 nodes in the cluster. So you have a better conservation of IPs with KubeNet, but there are other pros with Azure CNI. In KubeNet, you must manually manage and maintain UDR or user-defined routes, and to reach pods from outside the cluster, a load balancer must be used. With Azure CNI, pods get full virtual network connectivity and can be directly reached via their private IP address from connected networks. So for connectivity, Azure CNI is way better. Moreover, with Azure CNI, you can have multiple clusters using the same node subnet. It's not possible with KubeNet. Compared to Azure CNI, KubeNet needs an extra hop, which can introduce some minor latency. And also, I would say that Azure CNI supports complete network topologies, such as virtual nodes or Azure network policies. Finally, one important thing, with KubeNet, you can't work with Windows node pools. So if you want to run Windows containers, you will have to use Azure CNI. And just to be sure that you have understood which CNI you should use, here is a quick quiz you can find on learn.microsoft.com, and we're going to answer the question together. So which networking plugin prioritizes the conservation of IP address space? It's KubeNet. Which CNI supports Windows Server node pool? We have seen that it's Azure CNI. And finally, which CNI is best suited for production cluster? I would say Azure CNI. We have now reached our last diagram about Azure Network Services we can use with our AKS cluster. So the first one is application gateways. You can use the application gateway as an ingress controller called AGIC for application gateway ingress controller. It's an add-on that you can use as a level 7 load balancer to expose cloud software to the internet. So it runs in a pod within the AKS cluster, and it consumes Kubernetes ingress resources and converts them to an application gateway configuration. It will allow the gateway to load balance traffic to the Kubernetes pod based on URL routing. It can also manage TLS termination and end-to-end TLS. It works with public, private, and hybrid websites, and it also integrates a web application firewall. So it's a great tool to improve your security and performances on your AKS clusters. Then we have network policies. So by default, all pods in an AKS cluster can send and receive traffic without any limitation. So you can see network policies like firewall rules, I would say. Indeed, you will be able to define rules that control the flow of traffic. For example, we can think about backend applications that are only exposed to required front-end services, or database components that are only accessible to the application tiers that connect to them. And finally, Bastion host. Of course, you don't expose remote connectivity to your AKS nodes, and for that, you can create a Bastion host or a jump box in a management virtual network, and use the Bastion host to securely route traffic into your AKS cluster to remote management task. So that's it for today. It was a pretty long video. Usually I try to make it smaller than 10 minutes, but we had a lot of things to see, even if it was for the fundamental knowledge of network in AKS. So we have seen what is a CNI, which CNI you should use between KubeNet, Azure CNI. Of course, there are a lot of different CNIs such as Cilium, Flannel, or Calico. Then we have seen other services we can link to our Kubernetes cluster, such as application gateway, ingress controller, network policies to secure our traffic, and Bastion to secure the access to the nodes for our users. So thank you very much. Please subscribe to this channel, like, share, and comment this video, and I hope I will see you soon.